My name is Mohammed Ali Zerouali and I'm Technical Sales Manager at Tahook Precision Solutions. When you engineers give us a drawing with requirements, our goal is to do two things. First, we have to make the geometry according to the drawing and follow the tolerance requirements. Second, we have to make a service quality that's good enough. The way we do this is by getting both our basic parameters and our process parameters just right. In the next upcoming slides, we will take a look at each one of them and how they influence our choices in the manufacturing process. Starting with the basic parameters, we will choose the right machine depending on the geometry we have to make. On the screen, you see a short list as an example. We always try to determine the correct machine for the correct product. The product needs to fit under the machine has to have the capability to work with the correct wire diameter. It also has to have the correct accuracy range, and foremost, it has to be the machine that is least expensive. As you can imagine, if we always choose the most accurate machine possible for the job, it might as well be the machine that is more expensive than a lower quality one. After we have chosen the correct machine, we have to choose the correct wire in combination with this machine. Both the wire diameter and the wire material are of importance. We try to get the diameter of the wire as big as possible because we want to have a strong wire. But if we have a very sharp internal radius, then we cannot get into these small radiuses with a big wire. In that case, we will have to choose a wire which is smaller in diameter. If we want to make a feature that has a big gap like this one, we are able to fit a big wire. If we want to make a gap that is smaller, we'll have to choose a wire that fits within this gap. After we have chosen the correct machine and the correct wire, we have to determine the correct manufacturing sequence. In wire EDM, flushing is of utmost importance. So we need to have the flushing as good as possible. We want to give the feature with the highest tolerance or surface roughness requirements the best chance of succeeding. In the image, you see pink surfaces here and here. These surfaces need to be done using wire EDM. In the manufacturing sequence, we have to accommodate for a 0.4 surface roughness on the upper pink area. A surface roughness of 0.4 RA is quite challenging. Of course, it depends on the height, but in general, this is quite a stringent requirement. We choose to produce this upper area feature before we produce these other two features. Ideally, the pocket in the middle is milled after EDM. The reason for that is that we do not have this cavity here, and here the flushing conditions are better. So the manufacturing sequence is chosen in such a way that the areas that need to be produced that have the highest tolerance requirements or the lowest service requirements have to be machined in such a way that they have optimal conditions. After we have chosen the correct machine, the correct wire and the correct manufacturing sequence, we have to choose a cutting strategy. The choice of the machine and the wire limits our range of cutting strategies. So for example, this 0.4 RA example that we just saw earlier with machine A and height B would require multiple passes. Let me explain a bit more what we mean when we say multiple passes. When we cut with a wire, we use the first cut with as much power as we can get to get through the material in the least amount of time. The surface at that time is still very coarse. You can see that on the left. We have to bring the surface requirements down to 0.4 RA. For that, we need multiple cuts. In comparison to milling, for example, we don't use a different mill size or something like that. It's just still the same wire. But what we do is manipulating the offsets. We take the wire and we bring it a little bit farther away from the surface. At the same time, we use a lower generating setting. This helps decrease the surface roughness. We do that again in a third step, a fourth step, a fifth step, or how many steps we need to get to the surface requirements that we ultimately need. This is what we call the cutting strategy. Within this strategy, within each of these cuts, we will have to choose the technology. With technology, I mean the settings the electric generator will work with. You see here a table of one of our machines. In this area, you see the RA value. The upper RA value corresponds to the first cut. The RA values below correspond to the second cut, the third cut, the fourth cut, and so on. In this case, with this machine and in this example, we would need to reach the 0.4 RA in 5 or 6 cuts. In the left part of this table, you see the words high precision. In this case, it can be named differently on different machines, but in this case, it's a collection of technology settings inside of the machine that is appropriate to make a product that has really high tolerance requirements. As you can see here and here, you can only use this technology when both the wire guides on the top and the wire guide on the bottom are really close to the surface. In this case, the flushing conditions are ideal.